It's 9:30 in the morning and we're going to start. Good morning, dear friends, colleagues and guests. Welcome to the Biotech Healthcare Satellite Symposium at the 42nd Congress of the ESCRS. We are glad to have you all with us today as we explore some of the innovative advances in intraocular lens technology and vision care technology. On this platform, I would like to take this opportunity to congratulate Biotech Healthcare for celebrating 25 years. It's their 25th anniversary this year, so congratulations Biotech, and also their 10th anniversary of their phakic intraocular lens. Before we begin, I would like to introduce myself. I am Dr. Sri Ganesh, founder of Nethradhama Hospitals Private Limited and Shraddha Eye Care Trust, India. I am delighted to be a moderator today. And Dr. Carlos Lisa from Spain will be joining me, but she's a little late, so we will continue with the session. And I would like to introduce our expert panelists. So we have Dr. Renato Ambrosio from Brazil, who is affiliate professor of the Federal University of Sao Paulo and adjunct professor of the Federal University of the State of Rio de Janeiro. Professor George Mehta from Singapore, Deputy CEO of Singapore National Eye Center and Executive Director at the Singapore Eye Research Institute. Dr. Ertan Sune from Turkey, Medical Director at the Veni Eye Hospitals. Dr. Jose Lamarck from Spain, Deputy Medical Director at the Barraca Ophthalmology Center. Now let's turn our attention to our speakers who will share their experiences with the latest development in intraocular lens technology. After each presentation, we'll have a question and answer session to engage our speakers and panelists. So I'm the first speaker, and yes, let me start with my presentation. I would like to present my experience with the Optiflex XTENSE Comfort Plus. It's a new lens which is launched by Biotech, and it is a game changer in the presbyopia correcting IOLs. I am a consultant for Carl Zeiss Meditech and Biotech Vision. Let's look at the Optiflex XTENSE Comfort Plus. It is an EDOF lens, an extended depth of field lens, and it has an innovative refractive aspheric design for continuous vision. It has a unique zonal asymmetric power distribution on an aspheric platform, and this is inspired by natural vision. So let's look at the power distribution on the aspheric surface. So this is the design of the lens. It's got 5 zones. The first zone has a higher power to provide for near to intermediate vision. The second and the fifth zone have nominal power to provide the distance to intermediate vision. The third zone having the average power of nominal and higher powers to balance the intermediate distance vision. The fourth zone, as you can see, has segments, and it contains the nominal and higher power at 60-degree intervals to balance the energy in both photopic and scotopic light conditions. And then this is on you have a aspheric surface, and so with all the zones, they provide an extended depth of focus and continuous vision for daily activities. The lens can also tolerate large angle alpha and kappa. So to summarize, the new EDOF IOL has an aspheric surface. It gives you spectacle independence for daily activities and also an extended range of vision up to near distance. Photopic phenomenon profile is very similar to monofocal IOLs, and it's also available with a preloaded injector. So the unique refractive segment design gives you an extended depth of focus, which is achieved by optimizing the power and asphericity of each refractive zone. Optimized zones make the depth of field independent of the pupil size. The 60-degree segmented zone provides balanced energy for different light conditions, both in photopic and scotopic light. And smooth zone transitions minimize the unwanted photopic effects. So it has an extended vision up to near distance. So this is one of the EDOF lenses where you can remove spectacle dependency for daily activities, and it's got well-distributed energy for different object distances. And if you look at the energy distributions on the graph, you can see that there's a continuous vision between intermediate and near distances, and that's the energy distribution on the optical bench. This is the USAF images with the Optiflex XTENSE Comfort Plus. And as you can see, it gives you a continuous vision between intermediate to near distance for daily activities, up till 4 diopters, and then it reduces spectacle dependence. When you compare it to competitors like the Vivity IOL, both of them are EDOF IOLs. The XTENSE has a refractive technology with a very unique zonal asymmetric power distribution on an aspheric design. What is different is the depth of field at the IOL plane. It's about 3.75 diopters on an optical bench with the XTENSE, whereas it is 3 diopters with the Vivity. And at the spectacle plane, it gives you 2.8 diopters at 36 centimeters, whereas with the Vivity, it is 2.25 at 45 centimeters. So this is the through focus curve for the axis of Vivity, and you can see that it drops off after about 2 diopters. So it gives you some extended vision for near, but there's an unbalanced energy distribution for different object distances, and there is a compromised near vision. So patients will require readers and spectacles for near vision. The XTENSE gives you improved functional intermediate and near vision, and a continuous vision for intermediate to near. So here you can see the gray area, which is the gap between the Vivity and the XTENSE, and the XTENSE is the blue line. So you have almost like a continuous range of vision for distance to near, whereas with the Vivity it drops off after the intermediate, and so you need spectacles for reading. This is the comparison of the USAF images at a 3 millimeter pupil size. So you can see with the Optiflex XTENSE, distance and intermediate up to 2 diopters is fairly good. With the Vivity also, distance and intermediate up till 2 diopters is good. But when you come closer, you can see that with the Optiflex XTENSE, up till 4 diopters, the USAF images are quite clear, whereas with the Vivity, after about 2.8 diopters, the image quality degrades and drops off. This is just the implantation of the XTENSE, and you can just put in visco, and it's got a preloaded injector from MedCell, and you can see it's got a special wheel with which you can advance the lens in a very controlled manner. So you can inject it through a 2.2 mm incision also. And you can see that there's a very controlled injection as you advance the wheel, and you can insert the lens into the capsular bag. You can very clearly see the segments at 60 degrees on the 4th zone. But if you look at the light reflex, then you can actually see the zones. You can see the 5 zones, refractive zones, by just slightly moving the lens, and with the light reflex you can see the various zones. It's very subtle and it's blended in, but the 4th zone is quite clear because of the segments. Coming to the study, we conducted a study. This was just an initial evaluation. We still don't have a long-term follow-up. 45 patients were recruited, mean age 74 years, and we operated cataract eyes with no comorbidities. There were no intra-op or post-op complications, and right now we have a 1-month follow-up. So initial data, ideally we need to look at the 3-month data. This is the visual acuity at post-op day 1, and you can see that 81.54% were logMAR 0.1 or better. And this is the visual acuity at post-op 1 month, again 98.46 best corrected vision, logMAR 0.1, and 81.4% logMAR 0.1 or better. And this is the near visual acuity at 1 month, and you can see that 89.23% were able to read N10, so very minimal dependence on glasses for near vision. And same thing, 89.29 best corrected, distance corrected vision for near was 95.38, so quite good. This is the intermediate vision at 66 centimeters at 1 month, and you can see that 77.9, so 78% had a logMAR of 0.08 for intermediate vision at 66 centimeters. This is a post-op residual refractive error at 1 month, and 88% were within half a diopter, and it may further improve by 3 months and stabilize, and this may actually, the percentages may increase, and 100% were within 1 diopter spherical equivalent. The lens is still not available in toric, so we ruled out patients with significant astigmatism. So this is again the refractive cylinder, but again, like I said, it's not available in toric. 100% were within half diopter, and we expected that because pre-op there was no significant astigmatism. If you look at the vision satisfaction at 1 month, 94% said that they had spectacle independence. 94% said that they had no glare. Only 6% of patients complain of some amount of glare. And halos, nighttime halos, again in about 6% of patients, and daytime halos in about 5% of patients. 95% had no halos. If you look at the defocus curves at 1 month, you can see that you get a very smooth defocus curves. There are no peaks and valleys, and you have a continuous range of vision from 0 to about 3.5 diopters. So it gives you good spectacle independence. So to conclude, the Optiflex XTENSE Comfort Plus gives a good visual quality for all distances, with patient satisfaction being the highest for the intermediate vision, which we expect with an EDOF lens. Minimal visual disturbances with regard to night vision, glare, and halos, and it can give spectacle independence for most activities and patient's lifestyle. So it's easy on the eyes, whether it's morning or at night. Thank you very much for your attention.
Should we take questions now or save it for?
Yeah, I think we can have a discussion after every talk, or maybe we can take 2-3 questions.
May start?
Yes.
So, thank you for the invitation, being here. Congratulations. You're a superb surgeon, and I see how beautiful the procedures concluded in your hands. But my question is, have you had experience for this? 2 questions. First, how is the patient target if you do both eyes? You have both eyes target for plano, or you have one eye target for a little minimum partial mono?
Yeah, we always target for plano, because with this you get fairly good range of vision, and the near vision also is quite good. So we like to balance both the eyes, because as you can see, almost 3.5 diopters, the defocus curve. So once you do both eyes, there is a summation. So most patients are able to read fairly well, and almost 90% don't need any glasses. So that's the reason why we don't like to do a mini mono vision. Unlike other read-offs where you just get distance and intermediate, and then if the patient wants to reduce the dependence on reading glasses, then you have to do a mini mono vision.
So my suggestion is to include the graphs with both eyes, binocular vision.
Binocular.
That would be much
Yes, the
better.
binocular defocus curves would be better, and binocular near vision would be better.
So if I ask you, from your cohort, how many patients need glasses for reading in this cohort?
The spectacle independence was almost, I think, 94%. So just about 5%, 5-6% of them. But again, these are eyes where we have done only one eye. It's just a 1-month data. And even the refractive stability usually is achieved at about 3 months. So we need to wait for the 3-month data and also the results of bilateral implantation, because then you have summation and the number of patients requiring reading glasses may actually be less.
Have you had experience with post-refractive surgery, post-LASIK?
No, we have not implanted this in any post-refractive surgery patients.
Would you?
We'll have to look at the results long-term and the refractive stability. Of course, implanting an EDOF is an advantage because it's more forgiving for small errors in biometry and small refractive surprises. And since this has a higher range, so it's more forgiving than the other EDOF lenses. But we also have to look at the abrasion profile and then patient satisfaction. So we haven't done any. So once we implant them, then we will know how the lens does in post-refractive patients.
Yeah, it's beautiful technology. Thank you.
Thank you.
Okay, Shri, can I just get a couple of questions? I think what's the material of the lens?
This is a hydrophobic acrylic lens.
Hydrophobic, okay. And the other thing I was going to ask you was, you showed the segments of the refractive components in 4 zones.
Yeah.
So the question is really dependent, is there an effect of pupil dependency with respect to the outcome that you will get? Because your data that you showed for near vision, about 50% of them got N5.
Yes.
So is there a pupil dependent effect because you're in different zone sizes?
On the optical bench, it was measured at 3 millimeters because that is for the comparison with the other lenses. But basically, this is a pupil independent lens because on the 4th zones, you have an asymmetric distribution of light, and this kind of compensates if at all there is some drop in the scotopic vision. So because you have this segments, the 60-degree segments, which alternate for near and distance, so you have a kind of a balance in the light distribution, and this kind of compensates for the different pupil sizes.
Okay, thank you.